In algebra, there's a theorem called the remainder theorem, and it makes a connection between dividing a polynomial by a divisor of the form x minus r and the remainder that you would get from that division to evaluating the polynomial at a value. The remainder theorem is stated as such. If p of x is a polynomial, r is a real number or a non-real complex number, so this can be with real numbers or complex numbers as your r. P of r, so the polynomial, you get value out you get when you put r through all of the x's in the polynomial, that's p of r, is the value of the remainder when p of x is divided by x minus r. So if I was looking at just the remainder of the division, I don't actually need to do the entire polynomial division. All I need to do is take that value that is being subtracted from the x in the divisor and run it through the x's of the polynomial. The value I get out from that is the same as what the remainder would be if I did the long division or I did synthetic division. So here's an example. Find the remainder, so I just want to know the remainder, not the entire quotient and remainder, but just the remainder. When p of x equal to 3x to the fifth minus 2x to the fourth minus 5x cubed plus 2x minus 1 is divided by, and we're going to do two different examples, first x minus 4 and second x plus 1. Well, notice our divisors are x to the first and there's no coefficient in front of the x. So it has the right form that I can use this remainder theorem with. Now the r that you plug through the polynomial in for the x's is what follows the minus after it. So here x minus, my r in this first one is 4. So to find that remainder, I find p of 4. So I'm going to take out all of the x's in my polynomial and put in 4's instead. So this is 3 times, take out the x and put in 4, raise it to the fifth power, minus 2 times, take out the x and put in 4, raise it to the fourth power, minus 5 times 4 to the third, plus 2 times 4, and then minus 1. Now remember, we need to do our order of operations with this. So you need to do the exponents before you do the multiplication. So p of 4 is 3 times, well, 4 to the fifth power is 1024, minus 2 times, 4 to the fourth power is 256, minus 5 times 4 to the third power is 64, plus 2 times 4 is 8, and then minus 1. And then when you do these multiplications and then combine, you'll get p of 4 is equal to 2,247. So the remainder, when I take this polynomial, p of x equals 3x to the fifth minus 2x to the fourth minus 5x cubed plus 2x minus 1, and I divide it by x minus 4 and do the whole thing, the remainder would be 2,247. Now sometimes, just to make sure that you see the connection, they'll actually have you do both the p of 4 and divide the polynomial by x minus 4 and see that you actually get that number for the remainder. Okay, let's look at the next one. Still the same polynomial, but this time I'm dividing by x plus 1. Well, remember the r that you run through is what's following the minus after the x. So x plus 1 really is x minus a negative 1. So my r here is negative 1. So p of negative 1 is 3 times, take out the x and put in negative 1, raise it to the fifth power, minus 2 times, take out the x, put in negative 1, raise it to the fourth power, minus 5 times negative 1 to the third, plus 2 times negative 1, and then minus 1. And again, don't forget your order of operations. you have to do the exponents before you do the multiplication. So that's 3 times, well, negative 1 to the 5th is negative 1, minus 2 times negative 1 to the 4th is positive 1, minus 5 times negative 1 to the 3rd is negative 1, plus 2 times negative 1 and then minus 1. And then if you go through all of the calculations here and combine like terms, you are going to get a value of negative 3. So my remainder when I divide this polynomial by x plus 1 is negative 3.